A bullet of mass this 0.01 kg and horizontal speed this strikes a block of wood of mass this initially comes to rest with respect to block. Block is suspended from ceiling by thin wire. This is ceiling. This is a thin wire. This is a block of wood. Mass is m. This is a bullet. This is speed of bullet. A bullet of mass this. Mass of bullet is 0.01 kg. Speed of bullet u1, it is 50 meter per second. This is mass of block 0.49 kg. The bullet strikes horizontally, comes to rest with respect to block. The block start moving. V velocity of block and bullet, that is velocity of mass, capital M plus small. When this bullet hit with this, it gives its kinetic energy to this mass. So what happened? It moves and say this is the position. ये बुलेट, ये मास, ये कई हाइट पर पहुंचकर कहाँ आ जाएगा? रेस्ट में। तो हाइट कैसे आएगी? टोटल मास GH is equal to total mass, kinetic energy will shift into potential energy. So what we have to find? We have to first find this thing, velocity of this block when bullet hitting. According to law of conservation of momentum, mu1 mu2 this is momentum of bullet, this is momentum of block. The velocity of block is 0. After striking, this is momentum, this is total mass, this is what? Velocity. According to law of conservation of momentum. This is what? Momentum. before, this is momentum after. M 0.01 U1, it is 50, it is 0.49, it is 0, 0.49 plus 0.01 into B, which we have to find out. So this is what 5. This is what 0.5 V, or V comes out to be 10 meter per second. MU, it is 5 by 100, 1 by 2, it is 0.5 V, or V is 1 by 2, 0.5, it is 1 meter per second. According to law of conservation of energy, here the total energy is kinetic energy of block and bullet is equal to potential energy of block and bullet. Here we suppose it is at ground. Here it comes to rest, the total energy becomes potential energy. So kinetic energy half, क्या वेलोसिटी होगी ये, is what? This goes with this, or V square is 2GH, or V 2GH root, or V 2 is 2G, take G10, given, G is given 10, V is 1 to GH, we have to calculate. So 1 square is 1, it is 20H square, or H. H 1/20 or h 0.05 meter. A drop of 1 gram is falling down from height 1 kilometer and strikes the ground with velocity 50 meter per second. Calculate number 1, work done. By gravitational force. Number 2, work done by unknown force. This is a question. Mass of drop 1 gram, 10 raised to power 3 kilogram. Height 1 kilometer, 1000 meter. Velocity with which it hit the ground is 50 meter per second. First, W1, work done by gravitational force. It is mgh. G, 10 meter per second square. Take G this. M minus 3 G 10 H 1000. This 1000 goes with this 10 Joule. Second, kinetic energy of bullet. If there is no resistive force, then kinetic energy should be this much. Check kinetic energy of bullet. It is half mv square. It is half m. M is what? Minus 3 v square. V square is 50 into 50. It is 2.5. It is what? By 2. 1.25 joule. So where the rest energy is gone? That gone towards what? Unknown force, means resistive force. So unknown force work plus kinetic energy is work due to gravitational force. That is W2 is what? Work done by gravitational force. W1 minus what? Kinetic energy. W1, it is 10 minus 1.25. It comes out to be 8.75 joules. Another question. A ball of pendulum is released from horizontal position A as shown. The length of pendulum (1.5 meter). What is speed of bob at lowest point? Given 5% of its initial energy is consumed due to air resistance as shown. This is that pendulum, this is bob at position A. This is length. It is released, and this is what the position. Here velocity is v. What is given? Length 1.5 meter, g 10 meter per second square, we have to find g 10 meter per second square. So this is that L. So this L is h, height. Now potential energy of bob is what? mgh. I am not given g10 h 1.5. So this is what? 15 m joule. Kinetic energy half mv square. According to question, potential energy is kinetic energy. According to law of conservation of energy, if no energy is consumed, so how much this potential energy changes into kinetic energy? Only this. Why? 5% is wasted. So only 95% of potential energy changes into kinetic energy. Therefore, half mv square is 95 by 100 into 15 m. M goes with m. So v square 95 by 100 into 2 into 15, and calculate v under the root. It comes out with 5.28 meter. A police officer fires a bullet of mass 50 gram. With speed this on soft plywood. This is a soft plywood. This is what? Plywood. The thickness of this plywood is 2 centimeter. Bullet emerges out with 10% of initial kinetic energy. What is emergent speed? Let u be this speed. The emergent speed will be, say, v. So we have to find out v. What is given again? A police officer fires a bullet of mass 50 gram. 50 minus 3, 5, 10 p minus 2 kg. with initial speed u 200 meter per second. Initial kinetic energy, it is half mv square. It is half, it is m is this v square. It is 100. 100 goes with this. It is 1000 joule. Final kinetic energy, it is half mv square. It is 10% of initial kinetic energy. Half mv square, 10%. Initial kinetic energy was this. So it comes out to be what? 100 v square, 100 into 2 by m. M was 5 10 की minus 2. It is what? 20. It is what? 100 into 40. V square. V. 100 into 40 root. This is what? 10. 40. 10 into 2. 10. Take 4 also out. So this is what? 20 10 meter per second. This is the emergent speed of bullet. So this is meaningless here. Thickness. Another numerical, a body of mass 0.8 kilogram moving initially with speed (4i plus 3j meter per second, which changes to minus 6j plus 2k meter per second. Calculate change in kinetic energy. This is a numerical. Kinetic energy. A body of mass 0.8 kg. Solution. With initial speed u 4I 3j. This is u vector. Then u comes out to be this square plus this square under the root. It is what? 5 meter per second. V minus 6j plus 2k. V 36 plus 4. This is 40 root meter per second. Change in kinetic energy. It is half mv square minus half m u square. Half is common, m is common, v square minus u square. Half is half, m is 0.8, v square. It is 40, u square. It is 25. It is what? 0.4 with this 8 into 15. It is what? 6 joule. This is what change in kinetic energy. Another numerical. Find average frictional force. That book. Stop a car. Weighing 500 kg. At a distance 25 meters. If initial speed 72 kilometer per hour. Find average frictional force that would stop a car weighing 500 kg at a distance 25 meter. Initial speed 72 kilometer per hour. 72 5 by 18. It is 20 meter per second. Again, find average frictional force which would stop. Final velocity should be zero at a distance. This initial speed is this. So F MA. F is MA. First find A. S is given, V is given, U is given, we know. V square, U square, 2AS. V square is 0, U square. 20 into 22 is 2AS. 25. This is what? 400. This is what? 50A. A comes out to be by 50 meter per second square. Force, average resistive force is MA. M is this. A is this. So this is 0, 0, 0, 0, 0, 0, and one more 0. This Newton. So these are few numericals. Another question. Two bodies lighter and heavier are having same linear momentum. Which is having greater kinetic energy. A problem. Let M1, M2 be masses and M2 greater than M1. Then according to question, M1 V1 is M2 V2 given same linear momentum. This V1 by V2 comes out to be what? M1 by M2. Now, kinetic energies ratio is what? E1 by 2. This goes with this. E1 by 2. M1 by M2. A V2 square. Again, V1 by V2. It is M2 by M1. V1 by V2 square. M2 M1 square. So it comes out to be what? This M2 cancels with the square, M1 cancels with the square. So it comes out to be M2 by M1. As M2 greater than M1, therefore E1 greater than E2. ऊपर वाला बड़ा है इससे, so this will be greater than this. That is lighter body. वन कौन सी थी? M1 lighter लिया था हमने. Is having greater kinetic energy.